John for Year 13 Physics, and this is Lesson 3 for Linear Motion, and today's lesson is on Systems and Center of Mass. So if you appreciate my notes, give me a thumbs up, then I'll know I can carry on doing this because it's useful for you. So the concept of a system. The movement of a group of interrelated objects can be considered as if the group was a single object. The motion of a system of objects is analyzed using the idea or the concept of center of mass. Now, a system consists of two or more objects which are either stationary or moving. At any instant, a system will have a center of mass. The motion of the system can be analyzed by considering the motion of its center of mass. Center of mass of a system. The position of the center of mass of a system is that point in the system where it would balance if pivoted. The center of mass of a system can either be stationary or it could be moving. Now, there are two formulae that you can use to find the position of the center of mass of a system, and one is like your lever using the concept of torque, so that's your pivot or that's your center of mass. So mass times that distance equals the other mass times this distance. And if you use a reference point, sometimes this becomes easier, where the center of mass of the system, let's say it's over here, all distances are taken from a fixed point called the reference point. And if M1 is the mass of this plank, and the distance of the mass of the plank from its center of mass is x1, and let's say there's somebody on the plank with mass m2 standing at the end of the plank, and that's your x2. So the center of mass of the system is m1x1 plus m2x2 divided by m1 plus m2. Now the velocity of the center of mass can be found from the conservation of momentum. In case there's no external force, then the momentum of the center of mass of the system is conserved. So the center of mass will move in a straight line at constant speed. So this is the momentum of the center of mass of the system, and that is a sum of the individual momentum of the particles that make up the system. So that's what that's about, and I have a worksheet which I have solved. So in the diagram, A, B, and C show the positions every second of two ice skaters, father, which is the bigger circle, and daughter of mass 80. So the father is 80 kilograms and the daughter is half the mass, 40 kilograms, and they glide together over ice. Now, why is all this given? The glide together over ice tells you that there's no friction, so no external force, so your momentum is conserved. At C, the father pushes the daughter forwards so that she starts to move ahead of him, and the daughter continues as shown. So the black dots are the positions of the daughter. Now, this so it tells you what the distances are. So these little squares are 5 meters. So that's 5 meters by 5 meters. That's it. Okay, calculate the speed of the center of mass of the system of father and daughter before they separate. Speed is distance over time, so it moves 5 meters in 1 second, so it's 5 meters per second. Put dots on the diagram to show the position of the center of mass of the system of father and daughter each second before and after they have separated, and label the last three D, E, and F. So the center of mass of the system is where the red dots are. So every 5 meters you have the dot. So these, the center of mass of the system, will continue with the same speed in a straight line. And then on the diagram, mark the position of the father for each marked position of the daughter. So I'll show you a couple of them. So D, this is where the daughter is 1 second after they've separated, And so we got to find out where is the position of the father. This is the center of mass of the system. So the distance, so the daughter's mass is 40 times this distance should be 80 times the other distance. Father is twice the mass, so he'll be half the distance, and that's how you get that. And then E is the center of mass of the system. 2 seconds after they parted, this is where the daughter is, so mass times that distance should be equal to the father's mass times that distance. Okay, and F, the center of mass, the distance from the center of mass to where the daughter is so much, so the father will be half that because he's twice the mass. Okay, and then calculate the speed of the daughter and father after they have separated. So if you look at it, so in 1 second the daughter has moved 9 meters. Okay, so that's the distance, you just count the squares. And in 1 second the father, it's from here to here or from here to here, has moved 3 meters in 1 second. The momentum of the center of mass of the father and daughter, so these are their individual masses times the speed of the center of mass, okay, is that much. So that's 120 times 5, it's 600 kilogram meters per second. Now the individual momentum of the daughter and father after they've separated is 40 times 9 and 80 times 3, you get 360 and 240. But if you add these two, you come to that. So at all times, the momentum of the system is the sum of the momentums of the individuals that make up the system.